Hello there, and welcome to this, the third episode of our Expert Insights series, powered by Parker. I'm back as your host, Mark Jeffries, and today we're going to be delving deeper into electrification and exploring some of the latest developments and technologies that are happening right now, particularly in automotive and mobile platforms. You know, this is an area that's going to provide many opportunities for businesses in the coming decades, so there is a lot to discuss. Joining me today are Chris Griffin, Business Development Manager, Electrification from Parker Motion Systems Group, and Prasanna Srinivasan, Global Marketing, Business Development and Pricing Manager with Parker Engineered Materials Group. Welcome to both of you.
Thank you.
Thank you.
So before we go any further, I'd love for you to tell us a bit more about yourself and your responsibilities. Chris, I'll start with you.
Okay, well, my name is Chris Griffin. I'm the Business Development Manager focused on electrification for Parker's Motion Systems Group. And what that means is Motion Systems Group is where the hydraulic, pneumatic, and electromechanical motion technologies come together in one operating structure. So I've been with Parker for 27 years, mostly in what we call electromechanical. Some people call it mechatronics, and mostly in the factory automation space. But a lot of the technologies that we're using now in electrification emerged from that business. We've been doing it for over 10 years. But it's always been a trickle, but I would say in the last 3 years or so, it has exploded at astonishing speed, and we're starting to see so many inquiries from the market to electrify these vehicle platforms.
Yeah, it must feel like you've been on a journey for all these years, and suddenly somebody found the accelerator.
Very recently, somebody hit the accelerator, for sure.
Brilliant. Thank you for that. Prasanna.
Hi, yeah. So my name is Prasanna Srinivasan. I'm responsible for marketing, business development, and pricing for Engineered Materials Group. So I'm responsible for the automotive and electrification side of Engineered Materials Group. Been in the electrification side of things for almost a decade now, and just like Chris said, it's been a great journey. It's been an exciting journey. At Engineered Materials Group, we have a lot of solutions that we bring into the EV powertrain, and so we are excited to see where this journey takes us, and certainly excited to be here and talk about some of the progress that is happening in this market.
You're both in many ways at the forefront of the industry. And so I'd love to just really kick off with, I guess I would call it an opening statement from both of you on the importance of really where battery technology and connected systems all fit together from your different perspectives. So Prasanna, I'll start with you.
Yeah, so batteries are really at the heart of everything, right? So if you think about the internal combustion engines, the engine was at the heart of it. On the electrification side, on the EV side, everything starts with the battery and the powertrain around the battery. So, you think about where batteries have come in the last decade or, 12 years or so, the progress has just been incredible, right? From a technology perspective, in terms of range and faster charging, there's been incredible progress in terms of cost and manufacturability. Again, batteries have come a long way, and where electrification goes, where connected autonomous driving goes, everything is really going to be starting from the batteries and ending with the batteries. So, if you think about the lifeline, it's all about batteries, and so we at Engineered Materials Group, EMG, have a lot of solutions that I'll certainly be happy to talk about today that really helps with some of the things that are happening on the battery side.
It is all about the battery, right? Chris, what's your perspective?
Yes, I'm speaking from the perspective of the electrified motion. So whether that's what's driving the wheels or what's driving a pump that's creating hydraulic power, it all starts with the battery. It starts with the voltage that it's operating at, its thermal properties, its range, because that affects how you design everything that goes into the system. And as costs have gone down, obviously we're seeing these business cases becoming more and more viable for these electrified vehicle platforms.
Brilliant. And obviously, we all know this. There have been a fair amount of consumer and early industry motion and control technologies already being deployed. So, Prasanna, I wanted to ask you, when you think of heavier mobile applications, the applications still to come or just about starting now, where are you seeing existing technologies being already used and deployed?
Yeah, so, the innovation happens on the automotive side, and a lot of those technologies are getting ported over to other applications. You talk about heavy machineries, mobile industrial applications, and so the innovation is going to kick off on the automotive side, and then ported over there. And so you look at some of the materials technologies that we've worked on and we've developed, everything from thermal interface materials, where batteries are going to get hot and you need to get the heat out of those batteries, and thermal materials are going to be crucial to make sure that the batteries are operating reliably, efficiently, and last for a long time. So that's really at the forefront of what we do at EMG, right? Is thermal interface materials, and then once you have the battery pack, you need to assemble the pack together. Adhesives there are going to be integral in terms of getting weight out, in terms of making sure you can assemble the battery pack together. And then coatings, right? So there's a lot of functional coatings that help get weight out, that help drive the technology further and further. And then you have sealing technology that helps make sure that you protect the integrity of the systems. So all of these are technologies that Parker has been at the forefront of, and really are the market leaders. And as the market transitions from just automotive to electrification of all things moving, these are all technologies that are going to be crucial to enable that to happen.
Prasanna, let me ask you a follow-up question. We all know about the supply chain challenges that industry faces post-pandemic. And of course, when it comes to finding those essential materials and the rare earth minerals, how challenging will it be in the future, do you think, for the industry to find what it needs to create the future of batteries?
Yeah, I mean, it is a big challenge, right? I think everybody's seen sort of the effect of the pandemic and the pressure that it's put on the supply chain. But, even before the pandemic, one of the challenges that batteries technology in general has been facing, or sort of, facing a moment of reckoning, is around, the materials that go into the cathode. Cobalt, for example. Cobalt is a pretty rare, mineral. It's mined in a few locations. There's some issues in terms of it being a conflict mineral, right? So there's a lot of challenges in terms of some of those rare earth minerals being obtained out of the ground, and so it's going to put a lot of pressure across the industry in general, right? So there's already a lot of work underway in terms of tagging the batteries so that you can actually trace from cradle to grave in terms of where the materials are coming from. And then, of course, right, the pandemic has only made the challenge even worse, right? Getting basic materials has proven to be a big challenge. I think the great thing, I think, is the industry is talking about it. The industry understands the challenges. There's a lot of innovation and R&D going on to make sure that we can get out of, reliance on some of these, hard to obtain materials. So there's a lot of work actively underway to make sure that not only are the materials available, but they're also sustainably sourced and are going to be lasting for the next 100 years. So it is a big challenge, but like I said, the great thing is there's a lot of work underway to make sure that we can get around it.
Thank you for that. Chris, from your side of the business, Prasanna's covered the battery, but when you think about the crossover, what we can take from the already existing technologies, especially around, obviously electric vehicles, where are you seeing those touch points from your perspective?
Well, certainly I agree with Prasanna that automotive, certainly passenger cars, is sort of the entry point for a lot of this technology, and it's now feeding the adoption of electrification technology in some of these larger vehicles. But a lot of it started in the 1980s with the first wave of electrification, which was in the factory automation space. And Parker's been doing electrification, whether in the industrial space or in aerospace, since the early 1980s. And a lot of these technologies, such as motors and motor drives, were developed in these applications. And obviously we've learned from many decades of experience there, but now we have to adapt them for the mobile environment. That means they have to be more rugged, they have to deal with very nasty environments, and then the power source is different as well. There's no more mains power that you can always rely on. You're dealing with a DC power supply, whether that's from a battery or a fuel cell, and you have to adapt to that as well and the realities of that power supply.
And actually, following on from that, mobile, as you say, it's got its own share of challenges, but especially when it comes to safety standards. I'd love to know where you think the industry is on development there. How different are safety standards with an electric or electrified vehicle or solution versus the old world technology?
Yeah, so there have been safety standards that have been developed for the mobile space, particularly for traction applications. We have what's called ISO 26262, which is being adopted not only in traditional automotive, but also in electrified machinery as well. But the other thing that we're seeing with, particularly with the larger machines, where you're doing work, okay, so you're actuating, you're picking up heavy loads, and that has to be controlled. There are safety standards that we're adapting from the Industrial Machinery Safety Directive that was introduced in Europe probably 10 years ago now, ISO 13849, that is now being adapted to mobile machinery as well. Now what form it takes when it's finally finished will probably be a little bit different, but a lot of the same aspects of the conversation are there. And I would also say that I think the stakes are probably a bit higher in this type of equipment when it comes to safety versus a machine that's safely on a factory floor somewhere.
Thank you. Prasanna, I want to come back to you on the future of batteries. I've said this before, but we've all heard this said, that you use an example of an electric car like a Tesla. Obviously, we know that, roughly we're talking about $60,000 US. And of course, the joke is you're buying a $10,000 car, but you're buying a $50,000 battery. So my question to you is, when you look at the pathway that battery technology, or rather the advancement of it, is on, the pathway it's on right now, are we actually on the right track? Are we getting to a point where you can almost predict the developments that are coming and the improvements and maybe even the cost reduction in those batteries?
Yeah, I mean, it's always hard to predict where the technology is exactly going to go in the next 5 or 10 years, but there are some clear signs, right? So one of the indications is the cost of batteries. 10 years ago, it was around $1,200 a kilowatt hour. Now we're talking about anywhere between $140, $160 a kilowatt hour. Elon Musk has said it's going to come down to well below $100 a kilowatt hour, and I think most of the industry believes that that's where the market's going to go. So, it's a combination of innovation, it's a combination of economies of scale, and I think the cost of batteries will continue to keep going down and settle somewhere probably in the $75 a kilowatt hour range, right? So that's going to make it that much more appealing. One of the things that the common user is looking at is cost parity with internal combustion engine, and at less than $100 a kilowatt hour, you're absolutely going to get there, right? So the cost perspective, I think the trend is very clear. In terms of innovation, there's a lot going on in terms of trying to come up with new cathode technology. Like I talked about, getting away from cobalt, that's certainly one of the big initiatives. Changing the anode around, moving away from graphite into silicon, or even the holy grail, which is lithium metal. There's a lot of work going on to make sure that you can push the energy density boundary more and more so that you can get the longer range and trying to get the vehicle to run longer and longer, right? And then the last one is the next big step up in innovation is what is called solid state battery technology, where you replace the liquid electrolyte with a solid, and that's going to help you increase the safety of these batteries. That's going to help make sure that you can increase the energy in the batteries. That will make sure that you can actually increase the power density and charge the batteries faster and faster. So those are all some clear innovations that I think are in the pipeline, and that's going to be, each one is going to be its own little game changer, right? So we have a lot of really exciting things to look forward to from a battery innovation perspective in the next 5 to 10 years.
I like that. Thank you for that answer. Lots of great innovations coming that we know about, and who knows what could be around the corner, that it will be a major discovery of some sort. Chris, let me come back to you. There are people, especially in heavy industries, that will sit and listen to us and go, well, the really heavy work currently being done with hydraulic technology, that'll never change. Will it? Could that be a thing of the past?
I don't think it's ever going to be a thing of the past. There are things that hydraulics are good at that, in these types of environments, shock tolerance, dirty, dusty, it's just generally nasty operating conditions that hydraulics are perfectly suited for. But hydraulics can be improved through the electrification of the power source of the hydraulics. The other key, especially with batteries being such an expensive part of the system, is to maximize the range you get out of that battery. So, making the hydraulic system as efficient as possible can help enable the electrification of that motion. A hydraulic system, as it's currently designed on an internal combustion engine-driven vehicle, is probably 30, maybe 40%. And every percentage point of efficiency that you can gain makes a significant difference in the battery performance and obviously the cost of that battery system. So while we're never going to get to 100% with hydraulics, redesigning the system to accommodate the electronic control that comes with it can get you, let's say, 50, 60% efficiency, and that makes a significant difference in the viability of that platform to use battery technology or some other, such as fuel cells. That's really going to be the key moving forward. The other thing with hydraulics that you have to think about is noise. With a diesel engine running, a lot of the hydraulics no one even hears them. No one really thinks about it. But when you turn that diesel engine off and you run these pumps in these cylinders, for example, without that engine running, suddenly you hear noises you've never heard before. And when we introduce this to customers in a lab environment, that's the first thing they just step back aghast at the different noises that they hear. And so that's another thing that that's going to affect the hydraulic system design is how quiet can you make it once we get rid of that engine.
Isn't that funny? It's something people don't talk about much, the noise pollution effect. Well, let's extend the thought there around efficiency and pollution. And Chris, I'm going to stay with you. Obviously, there's a huge amount of interest around the world when it comes to climate, when it comes to emission control, and of course, sustainability. So when you look at this technology, you look at the journey we're all on, what do you believe it brings to the table in terms of those big focus points of the moment?
Well, it certainly provides an opportunity to reduce emissions. That's what it's all about, is reducing carbon emissions. A battery electric vehicle that maybe is driving hydraulics in addition to, driving itself from place to place, is by nature zero emission, although that depends on what's generating the electricity that charges that battery. But even a hybrid vehicle, where you have a combination of a battery system and an internal combustion engine, typically that engine's been downsized, so it's using less fuel, it's producing fewer emissions. So you even get some gains when you do that. Now, when we start to introduce things like hydrogen fuel cells, that will continue that journey to allow us to generate electricity through clean methods. Obviously, the infrastructure for hydraulic generation has to be established in a broader sense. But certainly everything that we do with respect to electrified motion on a vehicle has the opportunity to reduce carbon emissions.
Fabulous. Chris, thank you for that. I appreciate that. Prasanna, let me bring it back to you. And I want to end our conversation in a little while, looking ahead at the future in general. But for now, I want to ask you, we've talked about batteries, but where do you think the future developments in electrification technology will be made? So apart from the amazing innovation around battery technology, what do you think those future developments in general electrification technology might be? Where might they be made? Where are the investments going to be, do you think?
Yeah, so there are a couple of things, right? One is, as an extension of some of the changes that are happening and the innovations that are happening on the battery side, materials that go into the battery pack. We didn't really talk about that. And so when you look at what Parker is working on, that's exactly where we are putting our energy and effort into, which is to enable some of these next generation breakthroughs that are happening on the battery side. So for example, I talked about thermal management materials, thermal interface materials. Batteries don't like to get hot. I mean, the example that I like to use is batteries are like people. They don't like to be too hot. They don't like to be too cold. They don't like to be right next to each other. And all of that means that when the heat gets generated, it needs to be wicked out, and that's where thermal interface materials come into the picture. But the innovations that are happening on that front, it's really pretty mind-boggling, if you ask me. So, we went from very standard materials to materials that are now higher thermal conductivity, lower density, because weight is critical in EVs, as you can imagine, right? Getting the weight out through lower density materials, trying to increase some of the properties of the materials in terms of how long they can, stay open, in terms of the working life. Those are all innovations that we've made in the lab, and we've been able to commercialize some of those innovations. And then as you look at some changes that are happening on the EV market, there is a lot of interest in reworkability. So you have battery modules that could potentially go bad. These modules need to be replaced. You need to make the thermal interface materials reworkable, right? Where when you put the material down, put the battery module down, they bond very well together. They can absorb shock and vibration, but when you want to remove it, it needs to be easy to remove, right? So those are all sort of step changes in material innovation that Parker has been, able to bring to the market. So, you think about battery materials, it's not just the materials that go into the cells, it's also materials that go around it, right? And then when you look at outside the batteries, there's also innovation happening there in terms of charging systems, right? So, the interest in automotive EV is to charge the vehicle as fast as you possibly can, hopefully in a matter of 2 minutes, right? Just like you're filling in your gas tank. And so, for that, there is a lot of innovation happening. And again, Parker has been at the forefront of making sure that the materials that go into onboard chargers and power electronics like inverters and converters, they're all supporting some of the changes and innovations that are happening.
That's great. So much good work being done. Chris, I'm going to ask you a similar question, but we'll move it slightly. What do you think needs to be done to move closer to the future when it comes to how manufacturers should consider the challenge of electrifying their heavy vehicles? What are the conversations they should be having? What are the decisions that lie ahead? And do they need to be courageous and make moves that perhaps they're not even considering right now?
Yeah, certainly, as these manufacturers begin to electrify their fleets, it's not a simple case of just putting a motor onto your hydraulic system and off you go. A lot of changes have to be made. We talked earlier about efficiency being very important, and certainly to maximize the battery range, but also to make the vehicle operate better, to make the operator experience better. So a lot of it comes down to making the electronic system and the hydraulic system work together. And in both cases, the systems need to be designed together so that you can accommodate the capabilities and the advantage of the electric system, but also get the most out of the hydraulic system as well. So, it really for us means a lot of engineer-to-engineer contact, because there's no simple solution that's going to solve every application. Every machine is different. The number of axes that are on the machine is different. The duty cycles are different. So in each case, we have to work together to find that best combination of electronic and fluid power technology to get the job done.
So to either of you then, listening to what you were saying then, Chris, where does customization fit into this? Because to your point, Chris, everyone has a different need. How far can we customize as we continue to innovate and bring new products and ideas to the market? Where does customization fit in? I'll open that to either of you.
Customization is really the name of the game in electrification, as we've learned over the last 5 or 7 years at Parker. And the reason for that, what Chris outlined, right? So there is a whole variety of vehicles, types of vehicles, from really small vehicles to vehicles that are over 10 tons. And the duty cycle is different, the energy consumption and the energy profile is very different. You could have some OEMs and end users wanting really large battery packs that run for a long time. Some users are going to want smaller battery packs that charge really fast. In some cases, you're going to have OEMs that want to swap the batteries out. So, once the first pack is exhausted, they want to remove it and replace it with a new pack that is fully charged, right? So there's a lot of different varieties and variations that happen. And consequently, as a material supplier, we've got to keep pace, right? So we've got to be able to adapt. We've got to develop materials that are very specific for the usage profile and the very specific to meet the customer requirements. And that also means that our product development teams have to be extremely agile, extremely nimble in terms of trying to iterate through our designs. And if you ask me what is the single biggest difference between what internal combustion engine design cycles look like versus what electrification design cycles look like, I would say it's a fast turnaround and the customization and sort of the quick iterations that are required, not just at the OEM level, across the entire supply chain, right? So customization, either keep up or you get left out.
Outstanding. Chris, do you want to customize a quick add-on answer?
Yeah, my customization is that customization does come at a cost, though, as well. So, certainly there's a balance that has to be struck. And, what manufacturers try to do is have products that can be applied that are adaptable and can be customized in a manageable way. So, if you need to have a specific mechanical interface, or you want to, increase the performance of a component by a manageable amount, say 25% or 30%, without having to reinvent it, that's very important. And, with electrification, it's not so much about products as well, it's about systems. So it's really the choice you make in the combination of products that really customize the performance of that vehicle platform.
Makes perfect sense. Our time is almost up, so I'm going to ask you both one final question, and it's time to put your futurist hats on. And I know this is challenging, but when you think about the 5 to 10 year timeline, what does it look like in the mobile application sector? If we were sat here together in 5, 6, 7, 10 years, what sort of things might we be talking about? Just very briefly, and we won't hold you to these predictions. Chris, I'll start with you.
Well, certainly we've talked about battery costs coming down, and that's going to happen. And we certainly hope it's going to get below $100 per kilowatt hour, perhaps 50. And what that's just going to do is that's going to open the market for more and more vehicles that can make a viable business case to electrify. So we certainly see that continuing to accelerate. I would also say that the technology that electrification brings, which is this connected sense, where you can get data from these components, you can feed that to a fleet manager, you can feed that to a control system, is going to enable higher levels of autonomy than we're seeing right now. Certainly there's safety aspects to that, but certainly we're going to see more vehicle platforms that have some level of autonomous operation that we hadn't expected before. I think the other thing is the supply chains will be much more mature. I think it's not going to be as volatile as we've seen in the last few years. Obviously hopefully the pandemic will not be something we talk about in 5 or 6 years from now. But I think you're going to see some level of stability in our ability to get some of these materials like cobalt or rare earth magnets. So I think that's going to improve. And then lastly, I think we're going to be talking about companies that maybe don't exist today or we've never heard of today. So 15 years ago, Tesla wasn't something we talked about. And there's going to be another Tesla, whether it's in passenger cars or whether it's in mobile machinery. It's going to be someone who's going to break some glass, is going to make something change in the market that we're not thinking about right now.
I know, that's always exciting, isn't it? Trying to guess the unknowable. Thank you, Chris, for that. Prasanna, it looks like you get the last word with your predictions.
Yeah, so I think there's going to be a proliferation of electrification that extends well beyond automotive. I think all kinds of heavy equipment are going to be electrified. There's going to be some applications that are going to be, the penetration is going to be much higher than others. Mining is one application where I think it lends itself very naturally to electrification. So I think you're going to see a pretty heavy penetration of EVs there. We talked about solid state. I think in the next 10 years, that is going to become the dominant technology in terms of batteries. And then the last thing is wireless charging, right? So we didn't really talk about it. There's been tremendous progress that is being made as we speak in terms of wirelessly charging these devices. As you look at autonomous vehicles, autonomous vehicles go hand in hand with electrification and wireless charging, right? So I think there's going to be a lot of progress being made in wireless charging, and that's another exciting development that I think we'll all get to see.
That's an exciting future that you both painted. Thank you so much for that. And that brings our time to a close. So a big thank you to Chris Griffin and Prasanna Srinivasan. Thank you both so much indeed for joining us and for sharing your wisdom and your insight.
Thanks, Mark.
Thank you, Mark.
And a big thank you to you for watching. We hope you got a lot out of today's content, and we look forward to bringing you another episode very soon. Until next time, bye-bye.